G'day viewers, Alan here. Thanks for joining me in the workshop again. So in this video I wrap up the machining for the Lynx, but I made a bit of work for myself. I decided to make a flywheel rather than trying to start it with a propeller, and with the flywheel I wanted to put one of these toothed pulleys on it so I could use my cordless drill for starting it, and that turned into one of those detours where you make tools to make tools, etc. I'm sure you've all been there. I also added a breather to the crankcase and then started to get into the final assembly. So let's get straight into it and see how it all worked out. So I decided to knock up a flywheel for this engine rather than using a propeller, certainly at least for bench testing. For the first feature of the flywheel, I'm forming a boss on the front end here, which will be 24 diameter, so I'm reducing 70 OD down to 24. This is 4140, so yeah, it's it's reasonably tough. It cuts nicely though. Anyway, I've dialed the depth of cut up to 2mm for a total off the diameter of 4, and I've got a fairly aggressive feed to make the chips break. And they coming off hot, I can tell you that. Alright, well, let's go for it. Well, we landed on 24.008, and I imagine that when it finally cools down to room temperature we'll be about bang on size, so happy with that. So I bored an 8mm hole through this to suit the crankshaft, and that's a dowel pin, so that's fine. I'm going to bore this out to fit on there, and then I'll use that for starting. I don't know whether that's a good idea or not. I'd rather use a V-belt, but I haven't been able to find a suitable size one. But anyway, doing it the way I've got it in mind, I'll be able to take that off and put a V pulley on there instead. Anyway, so bottom line is I need to bore this out from 18 to 24. Now, learning from my previous experience, I decided that a split bush would be useful to hold it in the chuck. Unfortunately for me, I found that split bush lurking in this bit of old tube. So let's get this in the lathe and get it bored out. If you didn't watch the previous video to understand what I'm talking about, I had a drama with turning another one of these out to 18, and the problem I had was that I couldn't do it up tightly in the chuck because it would damage it. And during the operations, when I started the lathe on one occasion, the inertia spun the scroll and the thing came loose. Anyway, this method should completely eliminate that as a source of drama. So I can put a reasonable amount of tightness on that, all without hopefully not damaging the rim of the pulley. Right, well, let's get this guy opened out to 24. It's 18 at the moment. I'll just do a quick check to see how true it seems to be running. Happy with that, so we'll just touch off now. Alright, so I think we should be able to take reasonable cuts here. We're going out to 24. You go with a millimetre depth of cut and take it out to 20 to start with. So with that run I was set on 20, so we'll just see what we got here, because we've still got to calibrate the DRO. 19.98. Alright, I'll give this a quick measure, but really what counts now is whether that stub fits. Well, that's saying we're dead on 24. But the stub is not undersized. And let's just give a bit of a, give it half a chance of starting. that would press on, but I don't think I want it quite that tight, so I want to be able to get it off. So I did decide to give it another very light pass because I didn't want it to be tight. And as it is now, yeah, that's perfect. It's a nice sliding fit. I might just face that off a bit. Yeah, well, I can take that out now. Alright, well that it's got on there. It's turned out to be a very snug fit, exactly what I was looking for. So I haven't got any 1/8 inch key stock, so I'm going to have to make a piece. This is 3/16, so I'm just going to have to skinny it down a bit. So I'll just have to take that out of the fixture now and just check what the size is. It's going to left a reasonable finish anyway. Right, well that's measuring at 4.175, so I've got to take exactly 1mm off. Well, that came out pretty good. I think keys are supposed to be slightly under their nominal size anyway. I think the key is supposed to have the clearance on it rather than the slot. I don't know whether that's true, it just sort of seems that's what my limited experience suggests. But I'll wait till I've done the slot, decide whether or not I need to take any more off. So this should be the final pass that will bring it down to 1/8 of an inch square, or 3.175 square. Try to avoid that cutter, it's pretty sharp. Alright, well let's see how it turned out. So we've got 3.164 there, 3.169 there. I think that'll be close enough. We're struggling to get it any better anyway, so I think that'll do the job. Okay, so you see me make the flywheel with the boss, and that goes on there, but I'll have to do something to stop that from turning on there. So I've made up this 1/8 key. I went for 1/8. It's a bit unusual for me, I'm usually metric, but the smallest brooch I have is 1/8, so that's why I've chosen that. Now the way brooches work, you have an insert and you run the brooch down in there. That's 24mm. Not surprisingly, my brooch set didn't come with a 24mm guide bush. I think this one's 7/8, I think, or 22mm thereabouts. Anyway, so I've knocked up a 24mm body for a bush on the lathe, so now I just have to put that slot in there to house the brooch. Then I'll be able to put the keyway into the inner diameter of this pulley. Now I don't suppose it matters a whole heap, but the groove is actually 4.92mm wide. And I thought that must be because that's the version of any number of 64ths or something from the imperial system, but no, it's just for some reason some odd size. Anyway, so that's the groove I've got to do, 4.92 wide and towards the centre by 11.86. So that's the next move. So to cut this trench groove or slot, whatever you want to call it, I decided there's quite a bit of metal to come out, and there's a bit of depth as well, nearly 12mm. So I decided to use a horizontal cutter. This particular cutter's 4mm wide, so it will remove the bulk of the material. Then I should be able to use an end mill to open both sides out for symmetry, and hopefully get the size that I want. Of course, that's going to be a bit of a nuisance that once I've finished cutting with this setup, I've got to take the workpiece out and rotate it 90 degrees and get it all lined up again. But still, that's I think my best option. So that last pass was at 11.5 and we're looking for 11.86. Perhaps I'll do one more pass at 11.7. Right, well I've opened this slot up to 4.7 and the end game is 4.92. But as I thought, when using this to open it up, there's a bit of deflection on the ends of the teeth. It's definitely looser out here than in there. But that was the reason why I was originally thinking I might have to finish this out with an end mill. But that's a bit fraught as well, because a 3/16 of an inch end mill is not the stiffest thing in the world, especially over that. But I think it might still do better than this. Oh, and the other weird thing is that the trench is bigger here a little bit than it is down there. We're not talking much, you know, about 0.01 or something, and the only thing I can think of that would have caused that is if the spindle isn't perpendicular to the table, and so the wheel was dragging a little bit, and when it came out that side it started cutting a bit differently. I don't know whether that's what happened or not. It's a very small effect, but it's there. That's another reason why I'm thinking I might be better off rolling this around and going for the end mill. Right, after a bit of deliberation I decided to press on with what I've got. So this is another one of the guide bushes from the same set, and that's I wouldn't say, well, yeah, you can feel movement there, and at the other end you can't. So this isn't perfect either. And also this is basically a rattling good fit in there. I don't know how well you'd be able to see that, but that's actually pretty loose in there. The other thing is, of course, that it's only that bottom 6mm or so which is in contact with the groove. So the problem I'm talking about of it being, the opening being wider at the top than the bottom, is less important than I thought it was. So I'm going to press on. If a rattling good fit in there is good enough for the guys who made this stuff, it's going to be good enough for me. It's just that this was a tighter fit in the other one that's 22mm. So basically I'm going to take another 0.1 off each side. I might do 0.9 each side first. Well, that might have been the last pass. Let's do a trial fit. I'm expecting it to be sloppy and uneven, but we'll see. Yeah, it's not bad, but it's just too tight up that end. So I decided to try and finish this slot out using an end mill, and so to help get it set up I've wedged a couple of gauge blocks in there which are a firm fit most of the way down. And that's given me a reasonable reference point to aim for, and my alignment isn't perfect, it's pretty good. And I've also checked to make sure that the groove is running 90 degrees to the vise as best I can. So basically that's as good a setup as I can get, and I'm going to see if I can clean the sides down using a 3/16 end mill. Right, well, I've got the brooch now to be a very nice sliding fit, very nice indeed actually. I finished up taking 0.01 off one side, and that seemed to do the trick. I'm really surprised I didn't take more off, but anyway, that's what my instruments tell me, and this is now a nice sliding fit. But the next thing is to make sure that the slot is deep enough. So when the brooch first starts, the end here has to be, the groove has to be deep enough so that the end doesn't exceed the diameter. Well, this piece is 24 diameter. You can see from the micrometer it's sitting up proud by 0.235, so I've got to go, I'm going to say 0.25 deeper. Right, well that should have done this side. Has left a shoulder on that side that's going to have to come off. Well, that's nailed it. I think you can see now that the brooch is sitting down properly within the bush, so the clearance or the diameter over the brooch now is slightly less than the OD of the bush, 24, so that's great. Oh, I'm pretty happy with the way that turned out. It's a bit hard to take a picture of that, but the inside of the trench looks pretty good. And the broach slides really nicely in the guide. But more importantly, this is actually a very good fit. It really couldn't have come out any better. So happy with that. Let's go and see if we can cut a keyway with it. Alright, so we're putting the bush in the pulley, and it's a pretty snug fit. Might need a bit of persuading to go in there. Yeah, I'll just go and persuade it. Right, well, pulley going onto the bush decided to play hardball. Previously it had gone on without too much trouble. I think the aluminium picks up and starts galling a bit. Anyway, it's on, and you can see now also that the broach will start in the groove. Now, to explain something else, I was a bit worried. There's not a lot of material here, and I was a bit worried that when I put the force of the broach in here, whether it might stretch, distort, or even split this pulley. So to make sure that doesn't happen, I'm going to hold it in a 3-jaw chuck using that thing I used for holding it before, and I've made a washer up with the correct OD to fit inside that, and enough room for the broach to come through. And put the whole lot in a 3-jaw chuck. Right, now it's gone over the washer. Alright, so we'll turn it around so it something like that. Yeah, that should be good. We'll tighten the chuck up. I only need to nip it, I dare say. Right, so that should stop the pulley from changing its shape or size. And bring the broach into play. Now, broaches need lots of oil, so I'm going to have to stand this lot in a tray, I think, to catch the oil. Right, and it's very important when you press a broach in that it stays vertical, so we'll just check it from time to time. So it looks like we're off to a good start. You won't be able to see in this direction, but yeah, it's looking good. So we'll get lots of oil on it. Yeah, something near it. I have to be careful because this is a 30-ton press. It's a sledgehammer for a nut. So I let the pressure off from time to time just to allow this to stabilise itself. I think we run out of stroke on the ram. Have to come up a notch, and this is where the lifting hoist makes life so much more pleasant. And there we go. It's just enough height in my jig here. Alright, well, that's the first pass. Now, I won't bore you with it, but we do 2 more passes now, putting these down the back of the broach, and so that each pass takes the keyway out deeper. Well, that was so much fun I thought I'd do it twice. No, I made a mistake. What I didn't this is the first time I've done a keyway that small. I didn't realise with these little guys that you're only supposed to use one, which is marked for the 1/8. when I've done bigger keyways, you get a stack of 3 of the things to use. Anyway, so I used the 8th one and then used the 3/16 one before I woke up to what was going on. So I finished up with the keyway that was much too deep. Anyway, I decided to just cut another one on the other side. And my homemade key fits in there quite nicely. So I'm happy about that. So all I've got left to do now is cut the keyway in the hub on the flywheel. I guess that's next. So set up now to cut the keyway in the flywheel, 1/8 across, and I have to go in 1.6 millimeters. But I've got a healthy scepticism about how these skinny end mills can stay on track. So even though it's only 1.6, I think I'll do it in a couple of passes anyway. So we'll start off at 0.8 and see how that goes. Alright, well, let's see how that's worked out. Sorry, final test. I've cut the key to length, so hopefully this will now go on properly. It's a pretty close fit on the... there we go. There we go. Very happy with the way that turned out. Moving on to adjusting the valve lash now. I don't have adjustable rockers here. The only way I can adjust the clearance is by shortening the valve stem or putting a shim in the tappet bucket. But as I've got it at the moment, you can see the camshaft is rotating and there's no movement showing here. So there's clearance between the tip of that valve stem, which is the inlet valve, and the heel of the cam. So I'm positioned on the exhaust valve now. And as you can see, I think you'll be able to pick up, there is no clearance here. I've got a negative clearance on that valve. There isn't any part of the cam rotation that isn't moving the valve. So that means that the valve stem is too long. And to work out how much too long, we'll set this to 0, somewhere there. And now I'll let off the bolts on the back of the cam box so that the valve spring can move the cam box away, and we'll see how much the valve is then able to close. So the valve spring is free to pull the valve shut now, and you can see it only moved by about 0.02. So the valve stem isn't very much too long. I gather for an engine like this, 0.05 is sufficient valve clearance because the valve train is very short and the valve stem itself is short, so there really isn't much going to be much movement through temperature variation, which you might get in a bigger engine. Anyway, so I've made a note that I've got 0.02 movement there, so to get 0.05 clearance I've got to take 0.07 off the valve stem. So now I've moved on to the inlet valve, and now you can see that even though I'm rotating the camshaft, it's not, apart from a small amount of me just wiggling things, the camshaft itself is not moving the dial gauge. It's not until we come around to get on the cam that it starts to move. So of course what that tells me is that I do have clearance between the tip of the valve stem and the heel of the cam, but I can't tell how much. So what I'm going to have to do is put a shim in the tappet bucket until I do in fact have negative clearance, and then I'll be able to work out what the current clearance is and whether it's more than I want. Alright, so I've roughly cut a shim from 0.28 material. We'll just drop that in there, and now we'll reassemble it, and hopefully that's thick enough that I'll now be able to get a reading. Still not touching at the moment, so we'll make that 0. So that reading's pretty close to 0, so hopefully when I tighten up the cam box now we'll see some movement here. Yes, so now I'll be able to work out how much clearance I've got. Right, so the cam box is pulled up now, which has pushed the valve out. So that extra 0.28 has moved us from 0 to 0.22, so in other words the clearance was 0.06, which is pretty much exactly what we want. So it looks like I caught a lucky break there. So we'll just check that by letting this off, and hopefully it will go back to 0. Let this one off. Right. And we have indeed gone back to 0. Okay, maybe you can just see the tip of the valve stem there. I got a bit lucky. I thought I'd have to make a 3mm split collet to hold that, but that's my 3/4 ER40 collet, and with the valve pushed in from the other side it just sticks the tip out enough to work with. So I've got to make sure I get it very accurately set and then take 0.08 off. Well, hopefully that's it. I just realised I was bloody stupid. I should have measured the length of the thing before I did that, so now I don't have a check. Anyway, let's just take the chamfer on that corner a little bit. Right, all I can do now is put it back in and check the reading. Right, so I have it reassembled with the 0.28 shim in the tappet, and I've set the dial gauge to 0.28, and this is all bolted up firm. So if there's 0 clearance when I let this off, that needle should go to 0, but by however much short of 0, that will be the clearance that I've got. So it looks like I've got about 0.08 clearance. I'm happy with that. Right, that concludes the valve clearance adjustment. Right, I think this is the final machining operation for me on this project. I forgot to do this drain plug earlier, but I think after I've done this, what's left to do is assembly. And the main thing being setting the valve timing. This is just being tapped M5 for a drain plug, and thankfully the hole came out in exactly the right place. Right, machining finished. Okay, let's get into this assembly business. So we start off by assembling the crankcase front. Now that's got a locating diameter there into the bore on the crankcase, so it's actually quite a close fit. So I'll put 3 screws in to align it. So when I press it down, those holes will line up. Right, so with the nose cone on, and I didn't put the 2 top screws in because the cam belt tension has got to go on there in a bit. We'll put him in the background for the moment. So, a new feature which I don't think you've seen before. There's an extra hole appeared in the top of the crankcase here. That's for a breather which I've made up. At the moment I don't have the breather. I've only got the fixture or fitting I've made to attach it. That's an M5 thread into an M5 hole and another M5 on the top, so it's a sort of an extension housing if you like. But what it does is it moves the attachment plane of the breather when it goes in from here to there, and that's important because there isn't very much space. I think you'll be able to see that without raising the attachment there wasn't enough room next to the base flange on the cylinder to get a nut there, so that's what this is for. I've ordered something which I hope to insert in there as a breather, and I don't know how long that's, a few days away yet at least. So anyway, that's what that's all about. The tricky part though was finding out exactly where to place that hole, because you can see there's a hole there for a back cover attachment, there's a hole there for a side mount attachment, and these holes, there's holes everywhere. So working out exactly where to drill that so that it would come out without hitting anything else, that was a bit of CAD work and modelling. Anyway, that problem's sorted. So ready now to put the crankshaft in. I've already put the back bearing in and remembered to put the cam pulley in, lurking in the bottom there, because that won't fit through the hole. And now I have to put the cam belt in, because I won't be able to put that in afterwards either, obviously. We'll slip him in past the pulley. So now there's a lot of fiddling around to get the cam pulley in the right place. Oh, it just fell in. Could be lucky sometimes. Alright, so the cam pulley is now in the right place, and I can put the crankshaft in. Let's just back up a bit here so you've got a wider field of view. So there's a piece missing from here. Where's that gone? Ah, here it is. I made a little spacer collar, and its purpose, just sits on there. When I put the crankshaft in, that camshaft pulley will seat up against that, and that means I'll be able to align the holes, the securing holes, you can see those divots there. I've got to line them up with the holes in the pulley, and so this collar will make that possible. This other one here slips on the end there. It's a little bush assembly bush. It's just OD is slightly less than 12, so it will fit inside the bearing on the front, and the ID is slightly more than 8, so it's a loose fit on the crankshaft. And its purpose is just to centralise the crankshaft as it comes through the front pulley. So let's just come back a bit. It's going to be hard for me to do this and remember to keep everything all in frame. Right, so that first front bush is doing its job. Right, so that's a long way forwards, literally. Now I've got to fiddle around here for God knows how long to get that pulley in the right place and get the grub screws in. So I'll bring you back when I've achieved that. Alright, so I have one screw in. I think you better just see him there. And if we rotate the crankshaft a little bit, you see the other one's lined up with its divot as well. Just trying to see if I can get the screw in there without dropping it. As you'll appreciate, these aren't very big screws. Right. Now I haven't put Loctite on those screws at this stage, but I'll come back to that later when I've convinced myself that everything's alright, because it's fairly permanent putting Loctite on a screw that size. My life got a lot easier, by the way, when I realised I could turn the cam belt inside out, because when it's like that, it just kept getting in the way. I don't know why I didn't think of that before. Anyway, so that's the crankshaft in. Sorry, the bit on the front here was just to hold the crankshaft forwards while I was trying to get that pulley positioned. And one less moving target. I was just using, when I knocked that up, I was just using a joining nut as a useful piece of tube, and just put a spacer and bush in that end and turn the other end to match the front of the bearing. Anyway, enough of all that. So we've got the crankshaft in, and you see that's hopefully it's spinning freely. Now to get the before I put the cylinder on, I have to get the conrod on. The conrod big end has to float on the crank pin, and that's because the design is based on the ends of the gudgeon pin centering the piston in the bore. So it was quite a bit of patient polishing and finishing to get the big end to be a sliding but not loose fit. I don't know whether you can see that. It's a sliding but not a loose fit on that pin. So the piston will be able to set the conrod's position on the crank pin. That's the design. Right, let's get the cylinder on. Now, this can go on any way around. All my machining is symmetrical like that. Oh, I need the piston, don't I? Right, and the gudgeon pin. He's got to go on. Be nice if it went through the hole in the end of the conrod though. Right, and that's got that on. And I think I'll put a bit of assembly lube on that. And some in the bore as well. Should make the piston a bit happier about going in there. Okay, yeah, so slid in there nicely. Now, I'm not going to put sealant here because you'll have noticed there's a rim here, a locating ridge, which means there's a pretty solid sort of a baffle to the escape of any oil. It might weep out slightly. If it does, I'll worry about it if it happens. But anyway, come on, get on there. Right. So this is where the piston sets where the conrod should ride on that crank pin. So I've got the crank, conrod and cylinder all sorted now, and it's time to look at the screws to hold the cylinder to the crankcase. Now the drawing calls for 7mm long bolts, or 7mm of thread, but this flange is 5 thick, so that would have meant only 2mm of engagement with the top face of the crankcase. I wasn't happy with that, so I bought some 12mm, I'm not sure what you call these, button head maybe, but the shape of the head was optimum to get it in under that bottom cooling fin. So I shortened these 12mm screws down to 10.5, and they just fit. Actually, turning them up is not, as you might have imagined, is a bit of a fiddle. They turn in easily enough if you can get hold of them. And I had to cut down a 2.5mm Allen key to get in under that fin, which it does. Actually, this ball end Allen key helps quite a bit. I forgot about that. Anyway, that's got all of those tightened up. And you better see that this guy doesn't have a lot of room to play with. Just nip that gently for the moment. And as I said, that's a socket for a fitting which I don't yet have, which will just screw in there. I'll put that in as a placeholder. And start to button it up a bit now, put the back cover on. Right, really I'm at the point where I want to start doing valve timing. But the problem is, I can't permanently affix the flywheel. That goes on there. This flywheel is to have one of these expanding hub things, keyless hub things, but it hasn't arrived yet, so I can put it on. But problem I've got. So I think the last thing I can do while I'm waiting for my other keyless hub to arrive is work out a setup for finding top dead centre and practice using it. So that's what this is. The method that I've read about to use is to put a dial gauge to read the piston crown and set it roughly to top dead centre, which is what I've done. But you can see you can move it a bit without making very much difference to the reading. So the method suggests that you have a stab at where top dead centre is, and then rotate the crankshaft until you get about 10th thou or 0.2 of reading on the dial gauge. Note what the degree wheel says, and in my case at this point it's saying 7. If my old eyes aren't deceiving me, 7 degrees. I'll make a note of that. And then rotate the crankshaft the other way to get till we get the same reading, 0.2, and note the reading. So in this case I've now got 9 degrees, or -9 I suppose you'd say. And then we set the degree wheel so it reads halfway between those two numbers, which I think would be -1 degree. So we wind him back to -1. And that should be top dead centre. So my stab was actually fairly close. Right, anyway, so that's what I'll do when I've got my cam box and everything all on top. I'll set the top dead centre, and then I can set the valves. But what I haven't worked out is how to put any sort of a mark to reference mark for future use on top dead centre. Yeah, not sure what to do about that. Well, there turned out to be a lot more work making that flywheel than I was expecting, with a detour, making extra bits and pieces and jigs and fixtures and so on. Anyway, it was all good fun. So that wraps up the machining for the Lynx. I've gone as far as I can go now until the bits that I've ordered arrive and I can fix the pulley onto the camshaft and then set the camshaft timing. So I hope you enjoyed this one. I look forward to seeing you on the next one, and the wheels will go around next time. Whether we make smoke or not, the wheels are going to go around. So cheers.